All right, folks, good morning once again. Thank you for being a part of office hours. You guys are indeed diehard attendees. We have a new addition today. We have Lily. Welcome, Lily. Yes.
Oh, nice.
So we are going to go into the last Khan Academy exercise for this week. And the last Khan Academy exercise is this guy right here, which reads radians and degrees. Okay.
Mr. Chen, Lily isn't here anymore. He
Oh,
left
she's not
for
here
one.
anymore.
Yeah,
Oh,
exactly. It's Dylan.
it's Dylan. Morning,
Yeah.
Dylan.
Good morning.
Okay, so we're going to go into radians and degrees today, okay? And if you have not done so yet, okay, you should open up your Khan Academy and locate where radians and degrees is. I am going to do that. I'm going to go over here, and I'm going to hit next one more time. You should hit next like 14 times before you get to that assignment. So radians and degrees is this guy right there, okay? Everyone have this opened up yet?
I already have it opened.
Okay, great. So that's the exercise right there, and I'm going to put that on hold for a moment. I'm going to jump on my tablet, and I want to give you guys a little bit of notes, okay, as it pertains to radians and degrees. So give me a second. I'm going to present on my tablet.
So you're presenting on your computer right now?
I'm presenting. I'm jumping to my tablet now.
Okay.
Okay. This was calculus yesterday, so I'm going to erase all this.
Is that calculus?
That is calculus.
Oh, okay.
Okay, so we were on the subject of radians yesterday, okay? Or not radians. We were on the subject of arc measures yesterday. So just to be clear again, okay, in the past couple of lessons, in the past couple of office hour sessions, okay, we were able to have this understanding that theta here is the arc measure. I mean, is the central angle. Okay, and we actually have been using this term pretty interchangeably, okay, but we have like this understanding, okay, that the that section there that's highlighted in pink, which I want to call X for a moment, okay. There are two ways of interpreting this, right? That X there could be interpreted as the arc measure, right? And the arc measure is written. It has units associated with it. Okay, the arc measure. Okay, is it congruent to, or is it different from the from theta, guys?
It's different to theta.
The arc measure, actually, it's the same.
Why?
Right? Wasn't that what the exercises that we had gone last week, right? The arc measure and angle theta, right? The central angle, they are the same. Didn't we go through that?
Oh, we did. We went through that last week?
We went through that last week, okay? The arc measure and theta, they are the same, okay? Now, the only thing is, though, this week, beginning of this week, okay, we talked about something else. We didn't use the term arc measure to describe the highlighted section there. Instead, we used this term called arc length. And there's a subtle difference there, okay? The arc measure, okay? The arc measure here is measured in degrees, right? Because I said, or we've established this understanding, that the arc measure is the same as angle theta. Remember that?
Oh, yeah, I get it now. Okay,
Right?
okay. I was thinking about something different.
The arc measure is the same as the central angle. It is in degrees. However, arc length, okay, what units is that measured in?
Whatever unit is given, meters, feet, centimeters.
That's right. So a length, okay, is usually measured in inches, in meters, in feet, okay, centimeters, kilometers, okay, whatever unit of length it is, okay. And so there are really two different ways of interpreting this, okay. That we can have that section there that's highlighted in pink, okay, we can interpret that as the arc measure, okay, and it has an angle, okay, that's equivalent to the central angle, or we can interpret this as the arc length, okay. So the only thing is though, okay, these two things, the arc measure and the arc length, they're actually very, very much interconnected. They are connected, okay? They are closely
Wait,
related.
the arc measure is the same as theta, right?
Yes.
Oh yeah, now I remember. Okay, I was thinking of like arc length. Silly me, I was confusing
So
one
these
for
two
the
things
other.
are closely related, okay? They are so related that that it is actually more useful to think of the arc measure in terms of the arc length, okay? And let me just elaborate a little more, okay? These two things are very much closely related, and it is actually more widely accepted to interpret an arc measure in terms of the arc length only. Okay, so so a circle, okay, every circle has a radius, yes, okay, but there is one particular circle that is really important, and that's efficient in describing things, okay. So R, here is the radius. There's a really special circle, a circle with R equal to 1. We describe this as a unit circle.
What's a unit circle?
That's an excellent question. So
Thank you.
when R is equal to 1, we describe that as a unit circle. What is a unit circle? When you hear the word unit, okay, you actually see this word float around like in the real world as well. Like whenever do you guys remember when you went shopping with your parents to like in the grocery store?
Unit rate?
You hear about the unit rate, you hear about like the unit price, right? So when you go buy like fish, for example, right? Salmon, okay, they usually go for like, I don't know, like $10 a pound or something like that, right? That is a unit price. It's some amount per one quantity, right? Or the price of like, let's say, I don't know, the price of, I don't know, whatever you buy for pounds, rice or grains or fruit, okay, anything where you're buying things, okay, per one unit of something, okay. We always want to talk about a unit, okay, a unit price. So here, if we have a radius of 1, okay, we're talking about a unit circle. This is a unique circle, okay, where we can sort of basically base everything else off of, which is why this circle of radius 1 is of particular importance, okay? We're clear with that? So when R is equal to 1,
yes,
or when anything is equal to 1, okay, we usually refer to that as a unit, okay, as one unit, okay? And also it's sort of left a little ambiguous because there's no particular units associated with this, right? Like it's not, I'm not saying that it's R equal to 1 feet or 1 inch or 1 meter, okay? There's no specific unit of length, and that's because it's purposefully done that way, okay? So that it's applicable in all kinds of situations here. Anyway, a circle with radius of 1 is described as a unit circle. So why is this important? Well, it goes back to
Got
the things that I was saying, or we had a brief discussion the other day, okay, and that was 360 degrees, okay, is actually a man-made number, okay. 360 degrees is a man-made number to describe the degree measure of a circle. The person or the people who came to this consensus, okay, could have said, well, you know what, it may have been more useful to make the degree measure of a circle 1,000, okay, or maybe perhaps 100, okay. It could be any of those things, okay. But 360 degrees is a man-made number. The degree measure of a circle could have been 1,000. It could have been 100. It could have been anything. Okay, so it is yeah, and it's strange to think about this, like perhaps in an alternate universe, okay, somewhere else, okay, on another planet somewhere, okay, where people are, where creatures there are studying math. Perhaps when they talk about a circle, okay, they will think of the circle as, you know, in terms of something else, okay, perhaps maybe not in degrees. But anyway, this number is a man-made number, which is why for mathematicians this measure, okay, is not all that natural for them, okay. And I'm getting into a little.
What is the natural number?
Say that again. I'm sorry.
What is the natural number then if it's not 360?
It's not that natural way of thinking about circles. So then that's the next logical question, Michael. Like, what is then another logical way of thinking about a circle and the degree not degree measure and the arc measure that it has? Okay, so which brings us to the next to the next thing. It is actually way more logical and way more natural to think of the arc measure, okay, in terms of pi instead, because pi is not a man-made number.
How is that natural? Pi is an irrational number.
No, pi is like
Pi is an
nature.
irrational number, but yeah. Emmett, you want to elaborate?
Like pi is just a number that's found in nature. Like no matter what, you're gonna find it if you are doing a circle, even if it might be represented differently by, like, I guess, some other distant civilization.
That's right. That's right. Pi will exist like in the natural world. It will exist in the natural world in one form or another. Okay, that ratio of 3.14, you know, yada yada yada. Okay, that irrational number will exist regardless of whether or not we are here or not. Okay, but the number 360 degrees, that is a man-made figure. Okay, so because of this, okay, it is actually way more natural for mathematicians to think of the arc measure of a circle rather than a degree measure. Okay, so let me write that idea down. Okay, it is actually more natural. So it is more natural to think of an angle measure in terms of an arc measure, an arc length rather, rather than a degree. And the reason why it is so, it is because this concept of what a degree is, what is a degree measure, right? This number here, that 360 degrees, that degree measure, okay, that is a man-made thing. So it is counter to this whole study of math, because we expect math to be some like really natural, free-flowing idea, philosophy, right? we do not work with things that are man-made. We work with things that are in the physical world, which sounds very like philosophical right now, okay? But understand that 360 degrees, this idea of a degree, is a man-made thing. However, when we think about arc length, okay, this concept, arc length, okay, is a naturally occurring concept, okay? So the main takeaway is arc length is a naturally occurring concept, whereas a degree measure is not. Having said this, okay, then how do we correct this or make this idea of an angle measure, okay? Instead of measuring it in degrees, how do we? Is there another way for us to describe the angle? You may ask. Okay, well, 360 degrees, okay, is a man-made thing, and we're saying 360 degrees is equivalent to one full arc length around a circle. Okay, how do we find one full arc length around the most unique circle of all? Well, the most unique circle of all is, in fact, the unit circle, right? It is the unit circle. What is one full arc length going around a unit circle then? Does anyone know? Emmett?
2 pi.
It's 2 pi. Well,
2 pi.
it's actually 2 pi times 1, right? Why am I?
1.
Okay, so it seems like a little redundant. Why? Because anything multiplied by 1 is itself, right? But the reason why I'm pointing this out is because this thing that Emma just described for us, 2 pi times 1, is actually, what is that? Is that the area of the circle, or is that the circumference of the circle, guys?
Circumference.
This is the
circumference
circumference of the full circle. Again, this is the circumference of a full circle. And we understand that the circumference of a full unit circle is 360 degrees. Okay? Again, the circumference of a full circle is 360 degrees. So, it would be way more logical to think of a circle or the full angle measure going around a circle in terms of pi rather than in terms of degrees. It seems very counterintuitive right now because you guys are brought up this way, thinking about things in terms of degree measures, okay? And I get the confusion and the frustration. It's like telling your younger sibling, right? Hey, you know, there are more numbers than just whole numbers in the world. There are things like irrational numbers. There are these things that are like so minuscule that it's like that it's irrational to even think about, right? That's the same kind of concept that you guys should be grappling over at this point, right? Think about the very first time that you were introduced this concept of fractions, right? You will get that sense of confusion.
You said it's like telling your younger sibling. I don't have a younger sibling. I only have an older
Now
sibling.
that's funny.
It's like telling your younger sibling that what?
Not really. It's normal.
No, because like I don't have a younger sibling.
Oh, or maybe a younger cousin, perhaps. Okay, or maybe
I don't have a younger.
or maybe
maybe
a family friends that's younger than you, right? So somebody's that's younger than yours. Okay, it's like telling them like, you know, there are these things that exist in the world, and it's there, okay, and it's like their whole mind is blown, okay, at the moment. But again, I'm telling you right now, okay, it is way more natural to think of an angle measure in terms of the arc length of a unit circle. So what am I getting at here? Right now, this is all like philosophical, and this is all like not very tangible here, okay? So we will need to create some kind of a way to describe this concept. So instead of calling this an arc measure over and over and over and over again, okay, we will actually refer to this as what's called a radian measure. So this is called a radian measure. So this is a degree measure. Oops. So this is a degree measure.
Mr. Knan, quick question.
What was that? And
I have a quick question.
radian measure. Yeah.
Are
that
you one
pi
of those
is
mathematicians?
is a much more
that,
natural number to you than 360?
You ask
Are you one of those mathematicians?
you ask any math teacher and they will tell you the same thing, that it is way more natural to think of the angle measure in a circle as a radian measure rather than a degree measure.
Okay.
And 360 isn't a bad number though.
It's not like I have a personal bias. It's not like I have a personal bias or anything. It is one of those things that as you get older and you will appreciate this a little more, you will have like better fundamental understanding of this. Like I said, you know, as a kid, as a student, right, when you're first introduced to these concepts, it is hard to understand or digest. But with time, these things will grow with you and it will become like more it'll become more vibrant. Okay, but again, just to reiterate, right now we have two ways of measuring an angle. Okay, one is that is man-made, and that's with degrees, and another is more natural, to think of the arc measure. Okay, but instead of calling it the arc measure, it is widely accepted to call it a radian measure. Okay, and then there's a reason for why it's called a radian measure, because we're talking about this guy here. 2 pi, right, is the circumference for a radius of, for a circle of what radius again?
One.
It's a circumference for a radius of 1. That's why we call it a radian measure, right? Which is why it's a radius of 1, right? There's that word that's embedded in there, a radius, right? Anyway, so we have this, okay, this conversion right now, okay, 360 is to 2 pi. So, okay, there is a conversion, okay, that you should be aware of, okay, and that is this. Wait a minute. If I have some angle theta, okay, this guy right now is in degrees. That I need to try to convert from degrees into radians. How can I do that? Well, we can set up a proportion again. I can say theta over 360 is to, I'm going to call this guy here x, right? And this guy right here, I'm going to call this as the radian measure. Okay? The radian measure, okay, otherwise known as like the arc length of a unit circle, okay? What is the full length going around that unit circle again, one more time? What is the full length going around the circle, guys?
1.
Circumference.
Which is what?
1.
2
1.
pi times 1.
Wait, no, pi.
2 pi
Which
times
is
1,
2
yeah.
pi.
As Emma said. Right.
So guys, in order for me to figure out the conversion, okay, of what is the radian measure, if I'm given an angle in degree measure, okay, what I'm going to do is I'm going to cross multiply here. Okay, and what I will end up with as a result is I will end up with x is equal to 2 pi times theta over 360, right? And here, do you guys see any? Do you guys notice any factors that I can eliminate?
360 and 2, 180.
So I'm left with, I'm going to rearrange this a little bit. I'm going to write theta pi over 180. This is the conversion going from degrees into radian. This is the conversion, one more time, going from degrees into radians. So this is the conversion.
So it's kind of like a conversion formula, right?
Yes. Again, this concept does not feel natural to you because you guys were brought up ever since you guys were in grade school and introduced to the concept of a degree measure, that, you know, that an angle measure is measured in degrees. It's not quite so. This concept of a degree measure is man-made, and it is way, way more natural to think of an angle measure in terms of the radian measure. Okay. So anyway, that's the notes. Okay.
But how do
Yeah, Emmett, go ahead.
we know that? How do we know that, like, this, like, if there are other people out there in the universe, that they'd be using this too. Like, why do we think so highly of ourselves that we could think of something that the whole universe will use?
Because if there are other civilizations out there, okay, who are analyzing circles, and this circle, this geometry will exist no matter where you are, like anywhere in the universe, okay. No matter how they interpret it or what symbols they use, at its core, the concepts will be the same. The numerical value at its core will be the same. Okay, so the equation in which they write it in, okay, may look different. However, at its core, the numbers and the values and the relationships are still going to be intact. Okay, which is why this concept of a radian measure, okay, is way more widely used, okay, in higher level math than the degree measure. Okay, you're going to find if you pursue more math later on, right, that the degree measure, especially in engineering, that is, right, this concept of the degree measure usually is used to explain to like the general public concepts of things, okay, but amongst scientists and engineers and doctors, right, they never use the degree measure. They don't. Okay, let's take a look at the Khan Academy assignment here. I'm going to go back over here now. I'm going to stop presenting on my tablet, and let's take a look. All right. All right, so it says right here that convert the angle theta, which is equal to 8 pi over 9 radians, back into degrees, okay? Excellent. 8 pi over 9. So you guys you guys have paper and pencil handy? Yes?
Yeah.
I have paper and pencil handy.
Okay, so I'm going to go back to my tablet now together. I gave you a conversion formula, okay? And we're going to use that right now. I'm going to present screen again. Okay, so going back over here, the radian measure that they gave us was 8 pi over 9. 8 pi over 9. This guy right now, ladies and actually just gentlemen, so this 8 pi over 9, is that a degree measure or a radian measure? What did it say again?
Radian.
This is a radian measure. This is a radian measure. Okay. Okay. I gave you this formula, which was x is equal to theta pi over 180, right?
Yep.
Okay. Where x right here, okay, is that radian or is that degree? This is radian. And the theta over here is in what unit again? Degree. Okay. It was in degree.
Well, 8, that's
Degree, yeah.
Okay. So what are we trying to solve for within this conversion equation?
We're trying to convert the radians to degrees.
We're trying to convert radians to degrees. So right now, we know what the radian measure is. We don't know what the degree measure is. So what we're going to do is we're going to directly substitute this. Am I going to replace 8 pi over 9? Am I going to replace that in for x, or am I going to replace that in for theta?
X.
I'm going to replace that in for x. So this is 8 pi over 9 is equal to theta pi over 180. And I'm going to try to solve for what theta is, okay? Guys, anytime that you have the same things on both sides of the equation, what do we do? I notice I have a pi here and a pi here. What happens
Cancel.
now?
Cross multiply.
We don't cross multiply. We can cancel
them
them out. This becomes 8/9 is equal to theta over 180. Okay? I need to isolate theta, right?
Now you
Now we're going to cross multiply. Okay? So if I do that, I'll end up with theta is equal to 180 times 8 over 9. Rather than multiplying 180 by
1440.
8, why don't I just divide 9 into 180? How many times does 9 go into 180? 20. So this becomes 20 times 8.
20 times.
Or this is really just 160. Okay? So that's how you would do that. This is 160 degrees. That's the conversion there, guys. Okay? So this is 160 degrees.
Got it.
You know, shouldn't like I just realized
Yeah, he's got-
shouldn't we be able to figure that out? That like if pi is equal to 180, then 8 over 9 pi should be equal to 160 because of the fraction.
I love
Like
that.
8 over 9 x over 180 it would be.
That is actually a very logical way of thinking about it. And that is super. I love the fact that you are thinking about the formula and not applying the formula with like no face value, but you are interpreting it. And yeah, that's exactly what it is. That's another way of thinking about it. All right, let's take a look at the next one here. I am going to switch over, toggle over. So the next one here is you're given now theta is equal to 290 degrees, and we need to convert that into radians. All right, 290 degrees. Convert it into radians. So if I take a look at this, 290 degrees, now I have 290 degrees. Whoops. Kian, 290 degrees. Am I going to substitute that in for theta, or am I going to substitute that in for x? Kian, are you there?
He's here,
Okay.
but muted.
Michael, what do you think? Are you going to substitute 290
X.
in for theta, or am I going to substitute that in for x?
Is it X?
Theta, since it's degrees.
That's right. We're going to substitute that in for theta. So x will equal to 290 pi over 180. Okay? So wait a minute. Do you guys see a common factor between the numerator and denominator? I have 290 over 180. Is there a common
10.
factor that you see?
10.
10. So this is 29 pi over 18. And there's no other way of us reducing this, and that pretty much is it. So the radian measure of 290 degrees is simply that.
29 pi over 18. Okay, let me put that in. 29 pi over 18. Got it. 2 more to go.
Okay. Next one.
It's
convert
very
the
similar to the answer we got.
29 pi over 15 radians into degrees. Calvin, are we going to substitute? Hold on, I'm sorry. Let me just stop presenting here. Okay. Now we're back over here, okay? Is 29 pi over 15, is that a radian measure or is that a degree measure?
Radian.
That is a radian measure. Kian, are we going to substitute 29 pi over 15 in for x, or are we going to substitute that in for theta?
X, because it's a radian.
Excellent. So that's exactly what we're going to do. We're going to go back over here now. So 29 pi over 15 is a radian measure. So 29 pi over 15 is a radian measure. So 29 pi over 15 will equal to theta pi over 180. And what happens to the pi's there, Michael?
They get canceled out.
They get canceled out. I get 29 over 15 is equal to theta over 180.
Then cross multiply.
And now we're going to cross multiply. Theta will equal to 180 times 29 over 15. And before we multiply this stuff all out, let's get in the habit of just like reducing some of these things, right? If you notice, 180 and 15. Is there a common factor between 180 and 15 that you can see?
15.
15, right?
It's 12.
15 goes inside of 180 how many times?
12
times. It's 12 times 29. Okay, and whatever that is.
So now it's 12 times 29. That would be
So it's like
equal
348.
12, because 12 times 30 is 360.
Nice.
Thank you.
Okay. So it's 348.
So theta is 348 degrees.
Yep. Michael, you have very good mental math there.
Yeah, thank you. I just trained myself. It's pretty helpful, actually.
Okay, let's take a look at the last question now. So I have this guy, which is 35 degrees. Kian, am I going to substitute the 35 degrees in for theta, or am I going to substitute that in for x?
It's theta.
It's going to be substituted in for theta. Ricardo, can you help me with the substitution?
Wait, what was the answer for the third problem?
348.
Thanks.
Ricardo? Are you there, Ricardo? Ricardo?
He is muted
He's muted.
again.
Okay. So maybe Kelvin. We know that theta is equal to 35 degrees. Can you help us with the substitution?
Sure.
What would that be? Again, the formula is theta pi over 180. What is the substitution? How can you help me with the substitution?
Hold on. $35 over 180.
35 pi over how much?
180.
180. That's it. Okay. And then we got to figure out how many times does 35 go into 180, or perhaps is there a common factor, okay, that divides evenly into that? And the only one that I can see is 5 going inside both 35 and 180, right? So this becomes 7 pi over 30
72.
over
Oh yeah, it's 36. Yeah, 36.
36. Yeah. Okay.
72 times 2.5 would be 180.
Right. So we're going to enter that into the Khan Academy, right? So 7 pi
7 pi over 36. Got it. Wonderful. We completed it all.
Okay. All right. So I want to stop here. This lesson,
We have to.
even though it was pretty